Hello, good morning, and welcome to our new topic, geometric applications of the definite integral. So the purpose of this material is to discuss the methods of calculating the magnitude of important quantities which can be represented by the definite integral. So in the previous topics, we have discussed about definite integrals and how we can apply the properties of integrals in solving definite integrals. Right? So quantities which can be represented by the definite integrals. Quantities such as area of a region bounded by curves, volume of a solid of revolution, length of a curve, and the area of a surface of revolution. So for the first part, we are going to discuss about area under a curve. So in the previous topics that we have discussed, we gave an analytical definition of an integral, right? So, ma-recall siguro ninyo katong ato siyang relate sa Riemann sum. Since pareha sila objective, no? It is to um, summarize um, datas. Like, for example, sa Riemann sum, di ba, add, tas imuhang i-add, like, summation siya for a certain function. So, same nagyapon sila din sa integral calculus in which mas gina-practice na ang paggamit kang integral calculus compared kang Riemann sum. Pero si Riemann sum, magamit yapon ninyo na siya sa advanced mathematics. So, dinhi sa integral calculus, syempre, calculus na to ang i-discuss. Okay, so we also recall that the value of the definite integral is a real number, which depends on the type of function given and closed interval over the function is defined. So since the area of a plane region is a real number, we wish to associate the value of the definite integral with a given region. So as we have discussed in our previous topics, the main purpose or one of the purpose sa integral calculus is finding the area under a curve. So makita ninyo din sa figure 1.2, nagbutang ta og mga rectangles to estimate the area bounded by this region. So, under this curve, no? Okay. So, suppose that y is equal to f of x is a function which is defined or continuous on a closed interval a to b. Let R denote as the region bounded by the graph y is equal to f of x. The vertical lines x is equal to a is 1 and x is equal to b. So, mao ni siya ang limit sa ato ang function. And x-axis, this one. So, mao ni siya ang limit sa ato ang function. Okay? So, let A represent the area of R. This area is customarily referred to as the area under the curve. So, now we suppose, sorry. So now we suppose we are asked to calculate the area of the region R. So how shall we measure it? So a simple method of approximating or estimating the area of the region R is to construct a set of rectangles. So mo ni siya class. Atong slice nato to tiny or small rectangles. So the smaller the triangles or the thinner the triangles, for example, kung mas thinner siya dinhi, syempre mas duol ang ato ang estimation to the real value. Okay? So, let's construct a set of rectangles with bases along the x-axis. So the sum of the area of the rectangles will approximate the area of R. So for simplicity, let us divide. So mao ni siya ang graph. Okay, so let us divide the interval or so ato ang limit nga from A to B into n equal sub-intervals. So the number of intervals, okay, sub-intervals. Each length of delta x. Okay, so at each point, so x sub 0, x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, and x sub 6. So, naapod siya corresponding points along sa ato ang curve y is equal to f of x. So, notice that two sets of rectangles can be formed. Okay, so one set with the upper bases under the curve. So, inscribed triangles na siya sulod sa under the curve. Okay, na siya. Mao ni ang bounded na region. And the other set of rectangles is ang yahang upper base kay nilapas sa atong curve. Okay, or circumscribed rectangles. Okay, so let A sub 1 denote the sum of the areas of the inscribed rectangles. So, kini siya. Area of these rectangles, which is inscribed. And the sum of the areas of the circumscribed rectangles. This one. Circumscribed meaning ni overlap siya sa inyong curve. Then we have A sub 1, which is the area of the inscribed rectangles. So, F times x sub O times delta x plus f of x sub 1 times delta x until f of x sub n minus 1, dire, n minus 1, okay, times delta x, which is equal to the Riemann summation of f of x sub I times delta x from I is equal to 0 to n minus 1. Okay, that is our equation 1. So for our A sub 2, it is equal to f of x sub 1 delta x. Okay, din hita magsugod sa imuhang x sub 1, okay? Delta x until f of x sub n times delta x. So, dumduman nato siya class nga pag inscribe rectangles, diri magsugod sa iyang right side. So, kung sa ato ang circumscribe, diri magsugod sa sa iyang left side kung inscribed o sa right side kung circumscribed. Okay? So, if A is the area bounded by y is equal to f of x, and we have two limits, x is equal to A and x is equal to B, and the x-axis, then we set that as A sub 1 is lesser than A sub 2. Okay? So, ang area, total area yun din sa sulod, under the curve is greater than A sub 1 and lesser than A sub 2. Okay? So, sa atong approximation, okay, amo na to ang kanon sa atong approximation. Kining area din is lesser than, and kini po siya is greater than. So, we can get the total area ani nga curve by having this equation. So now we have equation number 3. A sub 1 is lesser than A, which is also lesser than A sub 2. Or 0 is lesser than A minus A sub 1, lesser than A sub 2 minus A sub 1. So that's our equation 4. So now we note that if we subtract 1 equation 1, this one. Equation 1 from 2, so mo na tayong subtract no, the summation of f of x sub I delta x from I is equal to 0 and n to n minus 1 minus nato kang summation of f of x sub I times delta x from I is equal to 1 and to n, okay? So we have a sub 2 minus a sub 1 is equal to f of x sub n minus f of sub 0 times delta x. So if the number of points of division is increased indefinitely, then delta x approaches to 0 as n tends to infinity. Okay, so as n approaches to infinity. So consequently, from equation 5, dere, ika na ning nag-derive na tong equation 5, we see that a sub 2 minus a sub 1 is approaching to 0. So that is the limit as n approaches to infinity of a sub 2 minus a sub 1 is equal to 0. So ma-derive na nato ato ang equation 7. So limit of a sub 2 as n approaches to infinity is equal to the limit of a sub 1 as n approaches to infinity. Also, since a sub 2 minus a sub 1 approaches to 0 and n is approaching to infinity, then by inequality from equation 4, this one, balikan na sa nato ni equation, we have a minus a sub 1 approaching to 0. That is, area A is equal to the limit of a sub 1 as n approaches to infinity. So that is our equation number 8. So therefore, by relating equation 7 and equation 8, we see that the area A is equal to the limit of a sub 1 as n approaches to infinity, which is also equal to the limit. So, wait lang. Sorry. So, from equation 7 and equation 8, so since is 1, so si limit of a sub 1 as n approaches to infinity, since it is equal to the limit of a sub 2 as n approaches to infinity from equation 7, we can conclude that area A is equal to the limit of a sub 1 as n approaches to infinity, which is equal to the limit of a sub 2 as n approaches to infinity. So the result of the above equation shows that the area of A of the region R can be found regardless of the way the rectangles are constructed. So either way, either inscribed or circumscribed rectangles, we can find the area A, which is bounded by region R. So in summation notation, kung magamit ta sa Riemann sum, so A is equal to the limit of n as n approaches to infinity of the summation of f of x sub I times delta x. So mao man ni ang kung nata sa atong graph, no, balikan nato atong graph. For example, kini dili ta malimot. For example, kung nato ang mga rectangles diri. Example nato mga rectangles diri. So mao man ni ang ato ang kini siya, mao man ni ato ang delta x. That is our delta x. Dayon si f of x sub I, mao ni siya ang ato ang y-axis. Okay? Ano siya? F of x sub I. Okay, balikan na to daw. So, mao ni siya. This one is our delta x. Then, kini siya mao ni atong f of x sub I. Okay, so length times width rin siya. Kung, di ba, atong ko ng area sa rectangle is length times width. So, length times width, tapos summation lang nato itong tanan ng mga rectangles under the curve. Okay? So, but the limit as n approaches to infinity of n of f of x sub I times delta x or length times width as from I is equal to 1 to n is equal to the integral notation of integral of f of x dx from a to b. So, hence, we conclude that the area A, under the curve y is equal to f of x from x is equal to a to x is equal to b is given by the definite integral. So now we have our equation 1.1, a is equal to the integral of y dx from a to b. Okay, so now this is our definite integral form. So if y is equal to f of x is entirely below x-axis, then the ordinate corresponding to each point on the curve is negative kung ang area nato is under x-axis. Hence, the area A of the region from x is equal to a to b is given by a is equal to negative integral of y dx from a to b. Okay? Kung below x-axis. Such as this one, meaning sa figure 1.5. So, if y is equal to f of x is partly positive and partly negative, such as shown in figure 1.6, then the graph y is equal to f of x crosses the x-axis like this. So, there are two regions. Okay? So, one is positive R1 and the other one is negative R2. So the total area is determined by a sub 1 is equal to the integral of y dx from a to c, so from point A to point C, and a sub 2 or the region 2 is equal to negative integral of y dx from C to B. Okay, so this one is positive and this one is negative. So, and adding the results, that is area is equal to area 1 plus area 2. So, the product y dx in equation 1.1 and 1.2, so from equation 1.1 and 1.2, is called the element of integration, and it represents a variable rectangle of altitude y. So, ang ato ang f of x sub I. And our base, which is delta x or dx. That is, if dA, or the derivative of A, denotes the area, delta A denotes the area of this variable rectangle, then delta A is equal to y dx. Okay, so note that our discussion above leads to a geometric interpretation of the definite integral as an area. Okay, so for example number 1, find the area under the curve y is equal to x squared from x is equal to 1 to x is equal to 3. So the graph shown in this figure 1.7, so this curve is our given curve, which is y is equal to x squared. So makuha na to ang point, ang points aning graph class kung atong i-plot, no? Then, from x is equal to 1, so this one, and x is equal to 3. So, ang ipangita nga ang area is this one. So, we solve the following problem by using equation 1.1, no? Area is equal to the integral of f of x dx, which is x squared, and integral of integral from 1 to 3. Okay, so the limit is 1 to 3. So solving that integral using the integral property, so we have x cubed over 3 from 1 to 3. So i-substitute na nato ang values ni 1 and 3. So we have 26 over 3. Okay? So, syempre, balikan lang nato ang mga properties ni integral. Okay? So, now, let's proceed with example number 2. Find the area bounded by the curve y is equal to 4 minus x squared and the x-axis. So, setting y is equal to 0, we find that the curve intersects with the x-axis. Okay? So, ang area mo daw nga itong pangitaon is the curve 4 minus y is equal to 4 minus x squared, tapos kini daw x-axis. Okay, so setting y is equal to 0, we find that the curve intersects the x-axis at x is equal to negative 2 and x is equal to positive 2. Hence, area, so the area of this region is equal to the integral of y dx from negative 2 to 2. Okay, so na ay straight line dali. Sorry kay dili yun siya straight. Dili siya straight. So kini. So kini and this curve. Okay, so now we substitute the value of y, which is 4 minus x squared. 4 minus x squared. Substitute natin dali. So we have the integral of 4 minus x squared dx from negative 2 to 2. So we apply the properties of integration. Then we have 4x minus x cubed over 3. So kini 4, that's na 4x. So magamit ang tag power rule, no? X to the power of n plus 1 over n plus 1. Ikan lang nato ang mga properties. Then we apply the limit from negative 2 to 2. Then the final answer is 32.3. Okay. Okay. So now we proceed. Okay, so dito lang sa tataman maghatag ako next na magtiwas lang ko aning second topic, which is area between two curves. Bye-bye.